Hello everyone. This is very first class to talk about Lean and Six Sigma. Before that, I want to have a deep introduction about measurement system analysis, or MSA for short. In order to analyze a measurement system, it is important to understand several key concepts and how they relate. For MSA, as you know, there are two types of data we can use for MSA. One is variable data, and other is attribute data. In use of attribute data measurement system analysis, the only evaluation principle is named kappa. The calculation formula is kappa equal to PO minus PA divided by 1 minus PA. In that, PO means probe of the observed value, and PA means probe of the accidental value. In Minitab, we can use attribute agreement analysis tool to calculate the kappa value, and then we can judge whether the gauge is acceptable or not, or whether a appraiser needs to have additional training. So, considering the attribute agreement analysis is not complicated, in this time, I will not take example to introduce more. If you have any question or answered item about this section, please leave your comments in the message room and I will reply for that. Today, we are mainly talk about MSA for variable data. For variable data, there are two key concepts. One is accuracy, and another is precision. Accuracy means the closeness of agreement between the measurement result and the true or acceptable reference value. Precision means the closeness of the agreement between the randomly selected individual measurement or test result. Be careful with that. Accuracy is focused on the difference compared with true value, and precision is focused on difference compared with measurement value. There is one figure to clearly illustrate the relationship between the accuracy and precision. Also, the components of accuracy includes another three concepts. First one is bias, the second one is linearity, and the third one is stability. Also, the precision includes two key concepts. One is repeatability, and the other one is reproducibility. These five concepts are really important for MSA, and then I'm going to talk the details one by one. Firstly, we talk about the bias. Bias means systematic difference between the mean of the test result or measurement result and the true value. As this finger shows, it is very easy for you to understand the meaning of bias. To be noticed that the bias is a gap between the average and the standard value. Yeah, maybe you are thinking about, I know the bias is important for MSA, but what is practical proposal for bias in your daily use? We want to know the practical purpose of bias, so the bias can be better used. Let me give you an example. If you use one caliper to inspect some parts, and there is always a constant inspection gap between this caliper and the true value, so we can get this bias value too close to the true value in your measurement result. So, one major goal for getting the bias value is to do the calibration and the compensation. And what's the cause of the poor bias. There are four major reasons. The first one is poor calibration. The second one is misoperation. The third one is undefined working instruction. And the fourth one is lack of skill. So, based on the different causes, we can perform the different corrective action to improve the bias. Next, we talk about linearity. Linearity means the difference in bias through the range of the measurement. I will show you two figures to give you a clear picture about what kind of linearity is good and what kind of linearity is bad. So, as the right figure shows, for a measurement system that has a good linearity, it will have a constant bias no matter the range of the measurement. By this time, maybe this same question rises in your hand. What's the practical purpose for linearity in your daily use? Let me give you an example. Imagine that you use a balance or scales to weight the parts, and you did the MSA for balance range in 10 gram and 100 gram. If you know that this balance or scale device only has a linearity relationship, so in this case, for the range of the measurement was from 10 gram to 100 gram, you can add a constant linear bias to get actual measurement date. And in order to make this much clearer, we are going to talk about the measuring and modeling relationship between the variables. The simple correlation coefficient R is a statistic that measures the degree of a linear relationship between two sets of numbers and is computed as correlation value of -1 and +1 represent the perfect linear agreement between two independent and dependent variables. When R equal to 0, there's no linear relationship. With MSA software, we can use scatter plot to show the relationship between two variable dates with a visible figure. And also, we can use regression section in MSA, and for this section, I will give you a detailed introduction in hypothesis testing. That section will be talked about later. Today, I will give you how to use the MSA software to get this scatter plot. Now, we switch to the MSA software and get the basic date. From the date, you can see that there are 5 samples being inspected, and each sample was measured by 12 times. And also, we get the true value for each test sample, and the actual inspection date are also be listed. So, we can start to analyze the linearity for this gauge and the linearity regression equation. Be careful that the gauge linearity analysis is calculated between the difference value and the true value. So, the first step, we need to get the difference value. Right-click with your mouse in any black cell of the columns and select the formula and assign formula to column. Select the inspection date minus to true value and then click OK. So we get a new set of date listed in column C4. We can name it with D-value. Then select graph and scatter plot. We get the scatter plot menu. In this menu, there are 6 options can be chosen. In this case, we just select simple and then click OK. When selecting which value should be y variable and which value should be x variable, it should be very careful. In this case, we want to get a difference value variable variation equation based on difference true value, or in the practical case, like based on different parameter range. So we need to put the d dash value into y variables and the true value into x variable, and then click OK. By now, we get the basic and the simple scatter plot between difference value and the true value. Different value on y-axis and the true value on x-axis. But in this diagram, we can get a very visible pattern to show whether the variables show any relationship. In order to achieve that, right-click with your mouse in any black cell. Select End and Regression Fit. Select Linear and click OK. From this regression fit line, we can get that these two variables have a negative correlation. In order to get exact linear regression equation, move to mouse onto the regression line and right-click, select Copy Text, and press Ctrl+V on your keyboard, and then we get the linear regression equation. Difference value equals 0.7367 minus 0.1317 times true value. And you can see the R-square value. R-square means the coefficient of determination, denoted R-square, where R-square is less than or equal to 1. In this case, R-square is 71.4%. That means 71.4% of the variation in y. That is explained by the fitted simple linear equation. Back to another question. In this case, we want to evaluate difference value at the different parameter range. If we want to identify which parameter range have the different value during the inspection, how should we do that to get the clear picture about that? Back to this diagram. All points on the diagram are difference value in that parameter range. So, in order to identify whether there is a bias value in this parameter range, we can compare the difference value with 0. In Minitab, in order to make it easy for visual identification, we can add the additional reference line. Right-click with your mouse in any black arrow, select End and reference line in y-value text field, enter 0, and then get the final scatter diagram. Okay, next part, we will talk about the gauge linearity and bias. In practical usage, linearity and bias are always to be evaluated at the same time. So, I will show you another way to get gauge bias and linearity analyzed with the Minitab software. To show you how to get this diagram and talk about what's the meaning of those words in this diagram. Let's back to Minitab software, and then we use the same date to do the gauge bias and linearity analysis. We just check the date again. In this date, we have 5 parts and 5 true value and 60 inspection date. Okay, we select statistic and quality tool, and then gauge study. In gauge study menu, we selected gauge linearity and bias study. In gauge linearity and bias study dialog box, we select C1 for part number and C2 for reference value and C3 for the measurement date. In gauge information menu, we can enter base information to identify which gauge you are performing the gauge bias and linearity study. So I put some information here and then click OK, and then click OK again. By now, we get the gauge linearity and bias report. In left scatter plot, we also can see the bias on the y-axis and the reference value on x-axis. Actually, it is same as the scatter plots we showed and done a few minutes ago. The only difference is that in scatter plot we need to manually calculate the difference value and mark the difference value on the y-axis. And in the gauge linearity bias study, they choose the bias on the y-axis. Compared with simple scatter plots, we can see that they enter the average bias for each reference value, and also you can find the 95% confidential interval line. In the right side display, you can see a lot of data. So I will talk about how to read it and what's the meaning for this data. In general, this data is divided into two blocks. Firstly, check the gauge bias block. In this block, you can find three columns. First column is about the reference value. You can see the average value and another 5 true value like 2, 4, and so on. And second column is bias value for the different reference value. The third column is very important, it is p-value. In the hypothesis testing section, I will talk about more details. But currently in MSA section, I just give you a basic criteria about how to use p-value. Actually, in different cases, the p-value has total different meaning and has total different criteria. In this case, if p-value is larger than 0.05, that means there was no clear evidence that the observations are biased. Conversely, if the p-value is less than 0.05, that means there was clear evidence that the observations are biased. So, back to this data, you can find that for reference value 4 and 6, the p-value is larger than 0.05. So, for reference value 4 and 6, there is no clear evidence to show that the observations are biased. Hence, for reference value 2, 8, and 10, due to p-value is less than 0.05, we can see that observations are biased for reference value 2, 8, and 10. Then, move to gauge linearity block. Firstly, we need to read the data p-value. We can see that the p-value of both constant and slope is less than 0.05. That means there was clear evidence to show that constant coefficient and slope coefficient is effective. Then we combine the predictor and the coefficient column to write together. So we can get the constant coefficient is 0.73667 and the slope coefficient is minus 0.13167. So we can get the linearity regression equation. The y equal 0.7367 minus 0.13167 times reference value. That's all about gauge linearity and bias study. Next, we talk about stability. Stability represents the change in bias of the environmental system over time and usage when that system is used to measure a mass part or scent. We always see some presentation to use these two charts to judge whether the measurement system is stable or not. What's the evaluation principle or MinTap tool can be used for stability check? First, about how to check stability. We use the same sample and same inspection device and only the different time or different place. For example, we use a caliper to inspect one particular part and record the inspection date by week and continuous record more than 1 or 2 months. Secondly, about when we use a stability check. In case the correlation media measurement or to check whether the gauge is under control or not, or in case of redo MSA is very expensive, especially like the destructive MSA. Okay, I'll talk about how and when to use stability check. Next, we talk about how to use MinTap to monitor the stability. Typically demonstrated through the use of the control chart, like IMR chart and X-bar chart. Detailed information about how to use IMR chart and X-bar chart, I will talk it in the control chart section. Next video, we'll talk about the last two concepts of MSA, repeatability and reproducibility, and also about how to use MinTap to do the gauge N study. Please make sure you subscribe my channel and click the below button to be notified about all the future updates. Alright, see you next video.